Thank you very much for that kind information, Dr. Munwar Basha. And thank you once again for Professor for the introduction. Let me go into the presentation directly. Is this viewable?
Yes, sir.
Yes, sir. Go ahead.
Okay, thank you. Very good morning to all once again. And this is, I'm going to speak on to the geotechnical application, the geotechnical engineer's role in Indian infrastructure development. Basically, in my opinion, the geotechnical engineer's role is the very, very prime and very important since he can only change the project on based on time as well as the cost part. So I can going to show you some of the few examples wherein a geotechnical engineer role made a very, very vital role, changing the course of the entire project itself. So with that, I will go into the presentation. You can go through that presentation and then you can identify and see that how important is the geotechnical engineer role in the construction, design and construction industry phases. Okay, I am going to take a few examples so that I can better explain on those process, how it has been developed. So this is one of the first project is the Kattupalli port, which is our own port, which has been developed for various activities. One activity was the ship lifting activity apart from the port. So this is the entire port. So this is the ship lifting facility, if we could see, where the ships have to be lifted and it has to be parked onto the behind land-based berths for any kind of a maintenance or a new construction also. And balance all our backup areas, which has been seen in the blue sheds. So this is the basic structure. I'm going to brief onto this structure. So this is the Google Earth map, where you can see the entire port, which is having the breakwaters and port structures. Boats are there on all along, and this is the location of our ship lift area. Basically, just give a brief introduction, because any geotechnical engineer, when he starts giving the his analysis and recommendation, what we have to do is we should understand first the structure and what is the purpose it is intended and how it is going to perform. Various performance requirement, loading patterns and loading requirement needs to be understood. So then you can provide the better solution, and how to do that we can take it up. So this is the one thing we can show it to you. This is the constructed views, and this is the ship lift platform, and this is the land berth you can see. And right side you can see this is the completed picture where the ship has to be moved. And this is the platform, steel platform, which is designed to take care of the capacity of 21,000 metric tons. So which means it can be expandable up to 26,000 metric ton also. So the next part, just I'll show you, this is the process actually. The ship is entering into the ship lift location, and the ship will be lifted by platform, and then with the CS of cradle supports, it will be moved to the land location, and then it can be shifted perpendicularly also. So then it has to be taken to its position. So these are all looking like a car which is moving like that, but you can imagine a 20,000 ton of vehicle has to move onto the land, and from the marine it has to be shifted and done. So I'm going to talk on two areas. One is on the ship lift platform, what is the foundation has been done, and another important point is this land berth, because this is it's kind of a ground supported raft which is going to take such a huge load. So this is the two areas which I will cover on this particular thing. So again, this simply platform is having a length of 200 meters length, and this width is say 46 meters. So this is a vertically lifting platform which is having a hoist. Series of hoists are there in this. So this is the hoist on both sides. So which will 68 numbers. This is having a capacity of 560 tons. If you see the next slide, 560 tons is the each capacity. This can be lifted, lifting vertically lifted by a suspended ropes, which is having a lift length of 18 meters vertically. So this is the function. This is the function of the entire ship operations. Now, what will happen when these are all the ropes which is going to be lifting the platform? This is the steel platform which is going up and down along with the ship actually. So now what happens? This ropes which is directly suspended has to be supported by the piles. So which means the pile has to be very rigid enough that it has very minimal settlement actually. Otherwise the ropes functionality of different location has to be difficult. So that is the most critical phase of this particular structure. So the initial phases, so it is very evident that we can go and achieve such kind of a stringent serviceability by providing a steel piles, a driven kind of a piles, wherein all the steel piles can be driven to the refusal strata, whereby we can know even the driving time itself, what is the resistance it offers and what kind of a settlement it can undergo. So that is the major crunch in this kind of a structure, where the steel piles are universally adopted for this kind of a ship lift platform. So now the challenge for geotechnical engineers is very given to us, since because the entire project, other projects, marine activities like the berth structure, port structure, and various marine activities are going to be executed with the board cast in situ piles. So as you are aware, the board cast in situ piles require a different set of equipments, fleets, and all those kind of accessories. Whereas the moment we go into the steel piles, an entirely different operations, because steel pile you need a yard for welding, you need to roll it and you have to bring it to the location, then you have to lift it with the crane, and then you have to drive with the different set of hammers for installing the steel piles. So the challenge was given to a geotechnical engineer, why can't you think of any other alternative, whether it is possible to keep this, even though the back of the mind, the settlement is going to be the very minimal vital part. Otherwise, in the universe, when we are going through the various process and the soil stratification, what we suggested was, we have gone to the
we are able to see the two slides. I think you can make one slide. I think the next slide also looking to the, maybe you need to swap or something, so that your the PPT will be bigger. I think maybe did you open two monitors or something?
No.
Display settings.
Is that okay now?
Okay, sir, go ahead. Still that next slide is also visible.
Okay.
Okay, sir, no problem. Go ahead.
Is it okay? Okay. So this is the process which has been done actually. Basically the investigation phase, where we have to assess the geotechnical parameters, and we have executed advanced investigation with the additional details for calculating the parameters in depth. And then we have gone into the engineering phase, wherein we have carried out sufficient analysis to find out the capacities. And the one prime decision we have taken is, we will allow the pile only up to the friction capacity. We will not take the end bearing behavior, as very well know that to mobilize the end bearing we need a higher settlement. Hence we limited the pile capacity such that it will only mobilize the friction capacity. So this is the engineering phase we have decided. Now moreover, after the engineering phase, we also have to look into the proving that our capacities are okay. So even though initial pile load test we have carried out and proved the capacity, however, now the series of piles has to be done. So what we did is we have taken extensive validation phase wherein a pile integrity test was been carried out for this all the piles, and in addition to that we done a load test on to the all these hoist piles alone 100% to take care whether all the piles are taking the capacity. So this is what we have carried out, and also we had a fallback arrangement in case after the load test anything is undergoing a more settlement. We had a fallback system also such that it can be plugged to take care the entire process. So that is how we have devised the entire geotechnical phases into the 3 phases, starting from the investigation, then the engineering, then on the validation phase also, so that we can look from start to the end of the construction, which means the engineering, geotechnical engineering role never ends at the giving the recommendation alone. He has to relook into what can be seen till the end of the construction, how it can be mitigated. Also, he has to overlook and see, and then he has to suggest and incorporate in his system while he is implementing itself. So that is the kind of a role we have developed in this and then adopted. And this is the final cross section which has been done with the both custom piles. This is the winch which is called hoist, which is going to lift this entire steel platform vertically. It's like a marine platform which is operated below water, and it is going to be lifted for 18 meters of the vertical lift. And this is the concept we have adopted for this marine piling system, which has performed. The other part which I was telling you about is the land berth, where the ship has been lifted and it has to be brought to the land for the various activities. So okay, 1 minute. I'll just close it and again share it.
No, sir. There is a display setting, sir. If you click, there is a swap or some view is there. Automatically, display settings on top.
I'll come out and see that.
Top frame.
Actually, presenter mode is on, so we have to switch it off.
Okay. Swap. It is not editable to me.
Actually. Yeah. I think there is a no problem, sir. You can go ahead.
Okay. Okay, that is not coming for me actually. It is blocked actually.
Yeah, understood, sir. I think they have to give permissions. It's okay, sir. You can continue, sir. No problem.
Okay. So this is the second portion of it. Actually, the ship has to be brought into the land, and then it has to be taken for the various activity. Again, the same, the ship lift, if you see, this is the cross section, and right down actually, so wherein the ship has been there and it has been placed onto this cradle beam, we call it as a steel beam, which will be supported the ship. And then the bogies are there on the right 2 sides, where it can be trawled like a vehicle, and it can be moved actually. So this is the kind of a thing. If I look at the cradle load, each cradle load is having a 240 ton as a concentrated load here, and the bogie is having a 4 wheels each, 1 meter apart, both directions. So it has 60 ton each point load, and which has to take 240 tons on either side. So this is the kind of a loading. You can imagine what we are designing the loads for our roads, which is multiple fold onto your ground. So the moment it has been seen these kind of a loads, then it has been decided that we will go ahead with the pile supported raft alone, such that it can take care such a heavy loads. So this slide shows that this is the system which has been devised, the initial proposal, that to take care such a heavy loads and it has to move. So we have to have a stringent differential settlement criteria, not the total settlement, because the differential settlement will drive you whether the ship has to climb up or not, because that is the most important rather than the total settlement. So with that differential settlement, we have relooked because of the time and the and the cost of the project is going up. So whether we have to look into the various other options, whether it can be done or not. So that is how again we have understood the requirement of this the serviceability requirement, and then we reworked with the different options, whether with the ground improvement we can do, whether the piles can be minimized, or any other offset replacement can be done. All these options we have been had a desk study. In addition to that, we had an extensive the finite element analysis along with the in situ testing. So rigorous analysis have been carried out, soil structure interaction, to understand the behavior, where it will go and what it will be done. So with that, actually, finally, we have adopted a rigid treated based concept, eliminating the pile, and understood the various level of problems, and then suggested this as a solution which will be workable. So with that, actually, we could able to manage to eliminate the piles for the project, and then we could able to suggest this and execute this. And this is the typical cross section where you can see the land berth is there. Below that, different type of treated base will be there to take care of the load, because since this is predominantly a kind of a wheel kind of a load, the influence is not going to be the much deeper portion. That is how it has been found from the analysis and then done. To implement this, again, these are all the filled up media. So the extensive field testing of each layers have been done, and that is how it has been executed. To see that, you can see the right side. Also, we have devised a dry run of this before bringing the original ship. So we made a dry run on this platform and seen whether what could be the differential settlement arrived, all these things are performing fine or not. That is how we have devised this. So these are the final pictures wherein you can see the left side picture is the ship lift platform, which is completed one, and the right side is the land berth. The next project is the river linking project. River linking project wherein we have to construct a river intake structure. Okay, this is one of the classical conventional pumpers which can be constructed in our country with the type of well foundation. Circular wells can be sunk into the well into the river, or the second position is the your typical 4-bay and pump house construction. So this is what it is actually. Then we relooked at the construction of such kind of structure will go into the timeline of 24 to 36 months, depending on the type of structure. Why? Because the wells, we know that we have to be sinking the large diameter well just to go down. And second thing is the construction of pumpers. We need to go for a proper excavation system, because it is in the center of the at the edge of the river. All the water seepage and stability of all this excavation needs to be taken care to construct this kind of a pumpers. So the challenge was posed to us is whether this can be constructed in a shortest period, because this is a river linking project. The water supply has to be faster. How much faster, that up to you. That is what the construction industry has been, client has told us what is the viable solution which I can deliver the water at the earliest. So that is the challenge has given. Actually, now the construction industry again re-looked into the geotechnical engineer whether any other solution is possible which can be carried out by shortest period. So then we could able to look into the various options. Why can't we construct the entire pump house itself with the kind of a Barrett pile system or contiguous pile system or secant pile system, so that it can act both permanent as well as temporary, like what we are doing in a metros, where the underground metros we are constructing the diaphragm wall itself as an excavation support measure also, as well as the permanent retaining wall also. So this is how we have extended the same principle in the water retaining structure also. So that is the basic idea with we could able to implement with the available technology we had actually. So the second thing is, since it is a water retaining structures, so we have adopted called overcutting of the existing panels such that it can have a better performance on the joints. So the next slide shows the typical layout of the wall panel. So we have devised this is a 24 chambers actually this particular project of length 210 meters and with the width of 17 meters. So each chamber is having 7 meters inside. So it's a closed box sections which is taking care the construction. So that is these are all the some of the pictures where you can see the construction activities with the kind of a technology this could be possible, and we could able to achieve a record time of 1 year completion of the entire system actually. So this is the first time actually. So such kind of an implementation has been done, and moreover, this also gave an added advantage to the client that the 24 chambers can be done in a staged manner also. Maybe a 4 chambers can be constructed and can be delivered the water if the downstream pipeline and other facilities are ready. So that is also done in that. So multi-stage level water has been delivered. So that is the greatest advantage of this kind of multi-cellular intake system with the diaphragm walls. And this is what I would like to tell. And thank you very much for this opportunity. Thanks.
Yeah. Thank you very much, sir, for a very insightful presentation on the foundations for the ship lift platforms. And also you are the second project, that river linking. It is really appreciated that, it was completed in a record time. That is 1 year. That is really appreciated, sir. So let me look at if any questions are there in the chat box. Okay. Okay, sir. Just I have one question to ask, sir. Sir, you said that initially, what is that? The settlement should be as minimum as possible, because I saw that it is a 560 megatons it is carrying. Sir, you said that you looked for the very minimum settlement. What was that settlement, sir? Allowable settlement for ship lift platforms?
We have kept within 5 mm as a settlement, because normally the piles codes allows 12 mm for the 1.5 times the load. So we kept minimum of 5 mm.
Okay, so generally for the shallow foundations we go up to 40 mm, but even raft, to 25 mm actually. But here I think you said that even a small settlement will cause a biggest disaster in the ship lift platform.
Yes.
Okay, sir. Yeah, thank you very much, sir. Sir, Raju, sir, do you have any?
We had thank you, sir. We had an expert and excellent lecture. I'm extremely happy. I too done some work in the same area, but I'm extremely happy, sir. This is really good, and we are happy with the presentation. Thank you, sir.
Thank you.